All right, welcome everybody back to the drive-through for a little 5-minute lesson. This lesson is on 8.3, which is the law of sines, okay? We can now do so many more word problems now that we know the law of sines. So congratulations on that. Some things to consider. This law works for any triangle, not just right triangles. SOHCAHTOA only works for right triangles. Law of sines works for any type of triangle, okay? Second point, I want to remind you that anytime you're solving for an angle, you'll need to hit the second key on your calculator. Take a moment and find that key. What's the opposite of multiplication? Division. What's the opposite of squaring? Square root. What's the opposite of sine? Sine inverse. You might hear that referred to as arc sine. Notice on your calculator, they're all right above and below each other. There's a reason for that. Okay? And then finally, this is important. There will be some of you that absolutely don't understand this, and you will absolutely get a question wrong because of it. Understand that the law of sines will never produce an obtuse angle. So you never want to find the biggest angle of a triangle using the law of sines. How would I do it then? Find the two small angles and subtract from what? 180. That's how you do it. If it wasn't a 5-minute lesson, I would mention more about this, but it's a 5-minute lesson, so we're moving on. Okay? Let's take a look at an example before I show you the law of sines. Oh, actually, hold on. Is the law of sines on the last slide? No, it wasn't. Well, I should give you the law of sines. So before we look for an example, I'm going to give you the law of sines. It is one of the most simple, beautiful laws in math. It just works really easily. First of all, start getting used to the fact that we're going to let our uppercase letters represent angles and our lowercase letter represent side. Also understand that the angle is always across from that side. Can you see that in the picture? Okay. Notice this is not a right triangle. If you knew that side C was the biggest side, then which angle could be an obtuse angle? Angle C. There's only one obtuse angle in any triangle. So if angle C was the biggest side, we would not want to find angle C using the law of sines. You'll get better at understanding that. Okay? So here's the law of sines. Sine of A is to A like sine of B is to B. That's a proportion. So they're in the same ratio. And also, these are in the same ratio. So that's the law of sines. If you want to copy that down, I'll pause the video. Okay, so now let's give it a look. Let me draw a nondescript triangle. 15, 10, and 9. Oh, hold on. I don't want to mess this up. Let me do something. Oh, no, I'm good. And let's say that this. Oh, no, I'm giving you too much information. I might be telling lies. I don't want to tell lies. Let's do that. Okay? Here's one example. There's going to be more examples I can give you, but I can't really go into the weeds on them until I tell you law of cosines. So those are going to be in the video for 8.5. Also, I'm going to be making the law of cosines video tomorrow, so there won't be a live performance for that because of our snow days. We're just a little behind on the videos. Okay, so can anyone set up this using the law of sines. Anybody want to do that? Okay, I'll do it. Sine of 27. What side is opposite of 27? Is to 9. Like sine of C, bless you, is to 10. Now, before you find angle C, can anybody tell me like a guess for angle C? If you get it within 5 degrees, I'll give you one of these stickers I have in my back pocket. Anybody want to give a guess? Oh, nobody wants a sticker. Thank you, Hallie. 35? Great guess. Notice she picked an angle that was bigger than 27 because 10 is bigger than 9. But she didn't pick an angle that was way bigger than 27 because 10's not that much bigger than 9. What you got, Cheech? 30. 33.
31.
And 31. Okay, the guesses are off. I think I have 4 stickers. These are butt stickers. I only have 3, but I have another one in the car. Butts on things. You guys ever heard of butts on things? This is my daughter's favorite thing in the world right now. They're cute. They're just pictures of things, but then they put butts on them. So, for example, what we have here is a Christmas tree with a butt on it. We've got two here, ice cream cone and an electric guitar with a butt on it. And we've got looks like a bacon covered donut with a butt on it. Butts on things. Anyway, here we go. All right, what are we solving for? We're solving for angle C. We're going to have to hit the second key, but not yet. We cross multiply. 10 times sine of 27 equals 9 times sine of C. Okay? Divide both sides by 9. This is where I think it's so much easier to use a graphing calculator because you can just wait and put it all on the graphing calculator at the end. So then you get sine of C is 10 times the sine of 27 divided by 9. What are we solving for again? Solving for angle C. What's being done to angle C? We're taking the sine of it. What's the opposite of the sine? Sine inverse. So we need to do the sine inverse of that, and these two will cancel, and that will give us angle C. So ready? In your graphing calculators, first, look up top. Are you in degrees? If it says radians, you are not. Okay, then hit second. Actually, I can show you this, I think. I can show you this. Notice I'm in radians because I just turned mine on. So I've got to go, get out of here. I've got to go to my mode and go down and go to degree and hit enter, okay? Now I'm good. Now it's switched to degrees. So I'm going to hit second key, sine. Now I want a parentheses, or I'm sorry, I want a fraction. So I'm going to do alpha y equals enter to open up this as a fraction. Now what was my thing? 9 times the sine of 27 divided by 10, or was it the other way around? Anybody remember? Uh-oh. And I made this up too. Does anybody have the picture written down?
It's 10 and 27 over 9.
Thank you so much. 10 times the sine of 27 and then divided by 9 and close. Oops. Delete that. Close. And it'll just give it to me. Bang. 30.23. Everybody gets a butts on things sticker. Good job. Everyone was within 5 degrees. Okay? Good job. Does that make sense? It's only a 5-minute lesson, so we don't have time to take a lot of questions, but you know I'm going to answer your questions individually. Let's get back to the show. So there's an example. Now let's prove it. This is actually kind of a wonderfully simple proof that I just learned 10 minutes ago because I didn't know how to prove this. I looked it up. Okay? Ready? A, B, C, A, B, and C. Okay? Now here's the key to this. Let's draw a right angle and call that H. Okay, our big B's out there. And now let's look at A and C in particular, side A and side C. If I looked at just this right triangle on the left, that's a weird phrase, the right triangle on the left, I could say that sine of A would be what? Opposite over hypotenuse. So what's opposite from angle A in the right triangle? H. What's the hypotenuse of the triangle on the left? It's C, right? Got it? So for this one, H would be C times the sine of A. Everybody good with that? Now let's set up another equation. On the right triangle on the right, sine of C would be what? What's opposite from angle C in the right triangle? H, very good, Caden. And the hypotenuse of the right triangle on the right? A. It's not very often you can use the word right twice in a sentence and have it have different contexts, but you can actually do it 3 times now that I think about it. This is fun. But anyway, solve this for H, and you get H equals A times the sine of C. Do you remember transitive? Do you see how A times the sine of C and C times the sine of A are both equal to the same thing? So then how does that make these two things related to each other? They must be the same. So C times the sine of A must be A times the sine of C. And if we just divide each side by C and divide each side by A, you're left with sine of A is to A like sine of C is to C. And that's how you prove it, using transitive. If you were wondering about the other one, you would just have to draw the other H and set up another proof. But we're not going to do that in the 5-minute lesson. I think that might be the last slide. Oh, no, I'm going to show you one more thing. As you can tell, it's being harder and harder to get these into 5 minutes. Boink. Boink. Okay. I don't know. They might teach this to you later, but this is going to be an important part of the law of sines. If you have A, B, and C, then the area could be 1/2 A, B, sine C. That's a different way to find the area of any triangle. This also works. 1/2 BC sine of A. And so what do you think the third one that works is? 1/2. Oh no, got to use my letters correctly. I hate not having the undo button on this thing. It just kills me. 1/2 AC sine of B. You are correct. I just need to write it in the right tense. And I am done with this lesson. Boom!